Okay. So Assalamualaikum and good afternoon. Afternoon. Yang recorded video, some of it yang Webex yang I ada masukkan, link tu actually you boleh check daripada post yang I post masa I post dalam GC about class tu, maksudnya link to Webex tu I masukkan balik, I edit the post I tak repost anything post baru I memang edit post, you tengok dalam tu ataupun you can check dekat YouFuture sebab ada recorded link, you boleh click on that recorded link if you want to refer balik to the recorded Webex. Kita buat latihan sama-sama. This one for exercise 1, you can refer to the handout last week ada exercise ni dalam that handout. So kita buat sama-sama on this question. Figure below is a multi-span beam with E and I being constant along its entire length. Determine the reaction on each support and draw bending moment and shear force diagram. So you look at the figure, then you tengoklah dia punya support and loading dia. The first step as usual lah, kita kena kira stiffness. KAB equal to KBA. Okay, sebab this one two span je. Soalan setakat ni yang you belajar tak ada lagi sampai 3 span ataupun 4 span macam tu lah. The maximum yang you belajar sampai 2 span je. KAB equal to KBA. Anis Natasha.
Ni Miss.
Are you around? Okay. So apa formula dia?
3AI over L.
Okay, betul. Then you dapat 0.5 EI. Okay, for KBC and KCB.
4 EI over L.
Adriana. Okay, thank you. 4 EI over L. Betul because of part and support dia is fixed. Divide by berapa tu? 5 meter. So since kita buat untuk AB kan, stiffness dia KAB lah. Now you have to divide with total stiffness at support A. So, dekat support A tu you just have one beam here that sit on the support A which is beam AB juga. Okay, therefore stiffness AB je lah. Dan you masukkanlah value KAB which is 0.5 EI dan you dapat 1. Then for distribution factor B ke A to KABA lah. Divide with, you look at support B. So support B you have beam BA and beam BC. Therefore total stiffness should be KBA plus KBC. Berapa Audrey? You ambil value ni 0.5, should be 0.5 divide by EI kan, 1 over 3 EI kan. Ni you kena campur dulu tau.
Okay.
Be careful on that.
0.385.
Okay, betul. Thank you. Okay, so for BC, kira DFBC jadi KBC lah. And divide with total stiffness at support B. Okay, macam mana you nak tahu, you kena tengok apa tau sebenarnya ni. You nak transfer dari mana, dia punya original tu kat mana support yang you nak tengok. Bila you nak tengok total stiffness dekat support tu. So sama juga for BC, total stiffness dekat support B So if support B it is 0.5 EI plus 0.8 EI sebab KBA plus dengan KBC. Then you just dividekan Hasmer.
0.615.
Okay, betul. Thank you. So BC dan CB. Last kali. So KCB lah. Divide with KCB plus infinity. Why infinity? Sebab dia adalah fixed and support. Fixed support dia memang ada that infinity. Macam mana ada beam yang panjang dia infinity, you don't know. Dia macam lah ada extra support lah sebenarnya. Sebab fixed dia very rigid. So dia ada that infinity beam that help to balance the load. Like that. KCB is 0.8 EI divide with 0.8 EI plus infinity. So jadi kosong. Okay, so kita dah siap on the distribution factor, then we can do the fixed and moment. FEM. Moment. So kita buat FEM AB dulu. So tengok the support AB ni lah. Okay, tapi before that, you kena assume dulu direction of the moment. But sebenarnya dia bukan assume. Dia macam cakap memang assume macam ni Jangan assume cara lain. Jangan buat dia ada direction This is the way we assume Sebab ini yang betul. Memang selalunya kalau moment, it goes this way. Dia takkan go the other way round. Takkan dekat sini you dapat moment arah dia macam ni. Tak ada That's why dia suruh terus you assume like this. So FEM AB, so kita tengok dekat support A lah. So kita assume dia counterclockwise. Okay. Therefore dia akan jadi negatif And then you look at what is the load that sit at the top of this beam AB ni, UDL. So negative WL square over 12. Okay, that is the formula. Berapa Adam?
12.
Okay, so negative 12 jangan tinggal negatif. Then we have FEMBA. So sebenarnya FEMBA ni sama je macam AB It's just that value dia positive. Sebab dia clockwise. Okay, sebab dia clockwise kat sini. I pun dah buat Kita tengok dekat support B sebab dia BA. B nak transfer to A. Tengok dekat support B 12. And then we have FEMBC. So tengok dekat BC lah. Okay, so for BC, this is point load. So you know formula dia is PAB square over L square. And also tengok juga direction of the moment. It is counterclockwise. Okay, jadi dia akan jadi negative. So negative P is 5 kilonewton. Darab dengan the value of A. So A here. So sekarang senang sebab jarak dia sama dekat sini. So you tak ada masalah mana satu A, mana satu B But for B ke C, A is this one and B is another 2.5 kat sebelah sana. You have to look at from here B to C. Anis Natasha.
BC negatif 3.125.
Negatif 3 berapa? 3.125 betul. Kilonewton meter. And last kali FEMCB. PAB square over L square juga sama sebenarnya sebab PAB square ni A dengan B tu sama value dia which is 2.5 so kalau you terbalik tak dia apa. Kalau from C to B, A dia is actually here. This is B. You kena tengok dari sini. Okay, but 2.5 so tak ada masalah value dia sama It is 3.125. Bila you buat semua ni, you confirm dapat 10 markah. Okay, daripada the stiffness, distribution and also sampai fixed and moment, it is 10 marks. Then we do for number 4, step 4, which is the distribution table. 12, negative 12 dan 12. Okay. DIST, distribution. So DIST is FEM times DF and times with negative. Kalau you rasa macam pelik kenapa darab negatif, you letaklah negatif 1. Sama je kan? Kita buat for AB. Siapa nak jawab?
12, Miss.
And then for BA. So for BA, please remember jangan tertinggal tambah ni dulu. Okay. Every time you nak buat distribution, you kena tambah dulu value yang you nak distributekan tu Because dia share support yang sama. Fatihah. Berapa BA?
Oh, negative 3.417.
Okay, thank you. 12 tolak 3.1. Okay, 12 tambah negatif 3.15. You akan dapat 8.875 here. And then you times with the DF and times with the negative one. Okay. For BC, Farah lah. Ni Farah. Berapa Farah? BC?
Negatif 1.923 ke?
Kurang tepat. 8.875 tu kan I dah campurkan 12 dengan negatif 3.155 ni I dapat 8.875. You darab dengan the DF which is 0.615 and then you darab dengan negatif 1.
5.458.
Okay, don't forget negatif sebab you darab dengan negatif 1 tu ataupun negatif So negatif 5.456. Okay, next. For CB, I nak jawab sebab senang, I tulis kosong. Okay, sebab kita ambil je FEM 3.125 times 0. You dapat 0, so darab negatif pun masih 0 Then we do for carry over. Okay, so carry over, you must have a look at you punya the beams itself. Nak tengok the end support So end support doesn't matter, anything yang dekat outside you boleh carry inside. But to carry outside, B tak boleh carry to A sebab that is pin support. Okay, ataupun roller dua-dua tak boleh sebab dia tak boleh resist moment, dia tak boleh support moment. The one yang boleh just fix support saja, so that's why you boleh carry B to C. Formula is distribution divide by 2. Since this one boleh carry over, you just have to divide with 2 So it is 6. Okay, and this one you cannot carry over, jadi kosong lah. BA tak boleh carry over to AB. So this one boleh carry over, yang ni pun boleh carry over. Kosong bahagi 2 masih kosong. 5.4 bla 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 ni apa ni. Bagi 2, you akan dapat negatif 2.728. Okay, then we move to distribution. Ini kan semua ni you tak payah tulis pun tak apa Ini I tulis sebab I nak bagi faham. I nak jawapan dalam tu je. Maka jawapan dalam tu So for distribution, I jawab this one kosong. Yeah. Sebab kita punya carry over value for AB is 0. So 0 darab 1 still 0 And darab negatif 1 masih kosong. And for BA, you kena plus these two value together first. Campurkan ia. Anis.
Negatif 2.31 ke, Miss?
So, thank you. Angelina. Can you answer for BC?
Negatif 3.69.
So, okay, thank you. And then distribution for CB 0. We do for CO. So, distribution divide by with 2. Divide with 2 This one you boleh carry over. Macam mana pun tetap kosong lah. So this one tak boleh carry over 0. Here you can carry over And ini pun boleh carry over tapi kena bagi 2 Okay, so belum kosong lagi. Buat lagi. Tapi ni tetap kosong Yang ni pun you campur pun dia masih kosong. So dia kosong lah. So, kosong. Okay, and last kali pun dah kosong dah because negative 1.815 times with 0 and times with negative 1. Kosong. We can start to calculate for final moment ataupun total moment dia. So final moment. Kira for each column dah. Starting from FEM sampai distribution. Campurkan semua. So, I dapat kosong kat sini. So, kita boleh kira reaction. Better draw the, what we call this? Beam so that, senang kita kira. So, RA, RB1. And dekat depan ni adalah UDL kan. So, dekat depan tu adalah UDL Also, we have one moment here. Clockwise. Sebab value final moment kita is positive. So dia clockwise So kalau you nak kira for reaction ni, you boleh je kira cara Dr. Izzat ajar. Sama je. You're going to get the same value. So I take moment dekat B equal to 0 and I kena darabkan dengan the distance which is 6 meter. Okay, and minuskan dengan UDL 4 kilonewton per meter. Since dia adalah loading, so dia turun ke bawah. So bila dia turun ke bawah, dia pushing dia macam ni lah. Okay, so counterclockwise, that's why dia negative. And then you darabkan dengan the length of the UDL. Sebab ni UDL dia kena darab panjang dia. 6 meter, and then because of kita nak cari moment, so kita nak kena dapatkan distance from centroid, which is half of 6 meter. And then don't forget that you dah kira the final moment for BA tu, which is positive 12.273. So campur lah, equal to 0. So boleh dapat RA berapa? Esther, okay, berapa value RA?
Negatif 9.95.
Tak ada negatif
954. Oh ya, positif.
Yeah, it's positive sebab you dah move dia to another sebelah sana, so dia positif. So 9.955. So RA is 9.95, then we can find the value of RB1. You nak pakai moment equation, nak kira RB1 pun boleh sebenarnya. Force equation lebih senang daripada moment equation. So RA going up, then we have one force, which is the UDL 4 kilonewton per meter, then for 6 meter kita kena darabkan, and then we have RB1 that we trying to find. Don't need to include that moment value sebab moment tu dia dalam moment equation, dia tak boleh masuk. Force boleh masuk dalam moment, moment tak boleh masuk dalam force equation. Therefore RB1 sama dengan berapa? 14.045. Okay, so kita dah siap for beam AB. Next we do for beam BC. 5 meter RC, RB2. Berapa value dia? 5 kilonewton. This one. Okay, so kalau you tengok dekat sini, you dapat value moment ni negatif So bila moment kat sini negatif, you kena ikut apa yang dia dapat lah. Kalau negatif So maksudnya this is negative 1.449. So it's not exactly, but kan kita assume dia clockwise. Tapi you dapat dia counter clockwise. Negative 1.449. So dia buka arah macam ni. Dia the other way around. And the one yang RB2 ni negative 12.273. Okay, so this one is 12.273. Kita kira RB2 pakai moment equation. And then minus 12.273 kilonewton meter. Okay, dah ada moment. And minus lagi dengan 1.449 kilonewton meter. Sebab you dapat moment tu negatif juga So ada dua moment yang negatif dekat sini, dan you boleh calculate RB. We do force equation. Okay, you akan nampak pelik sikit sebab RC ni you akan dapat value dia negatif. Biasanya reaction kan memang ke atas, mana reaction turun bawah. Moment ni dia cause the beam to bend So you nak avoid bending, you kena provide support. So tak mestinya support tu mesti pushing up the beam upwards. It also can push down juga. Dia adalah support, dia nak balance kan sebenarnya. Okay? Tak semestinya dia push support ke atas. RB2 minus 5 kilonewton plus RC equal to 0. Okay, so RB2 is 5.244 kilonewton. Minus with 5 kilonewton plus RC sama dengan kosong. Dan kat sini dapat, so RC you akan dapat negatif negatif 0.244 kilonewton. So kita stop dulu kat sini dah 4.57. Kita proceed next week So next week baru kita kira the SFD and BMD. Thank you so much.
Miss betul.
Miss betul. You jangan percaya sangat. I banyak menipu. Okay. Thank you so much semua. Have a nice day. Stay safe. Stay healthy. Jangan
Thank you, Miss.
register My Sejahtera for vaccination.